In this lecture, we're going to speak about the basal ganglia or basal nuclei. It depends on the textbook which phrase you're going to hear. I'm going to talk about them as the basal nuclei because they are a group of neurons within the central nervous system that function together with common targets, common inputs, and common neurotransmitters. And in the Haynes textbook is one you might run across. He calls them basal nuclei, and so I am too. Basal nuclei really are the neural basis of habits. And we define habits as sequential, repetitive motor behaviors elicited by external, internal triggers. Once activated, these behaviors are completed without constant conscious oversight. For example, once you start walking, you don't have to think about walking. You can check your cell phone, you can listen to music, you can chew gum, you can do all kinds of things while you're walking because it's a habitual, sequential motor behavior. These are the different components of the basal nuclei that we'll be discussing in the next part of this lecture. The caudate and putamen are both part of the brain called the striatum. The globus pallidus is part of the pallidum. The substantia nigra, or brown spot, is found within the brainstem, and the subthalamic nucleus is part of the diencephalon. We haven't talked about the diencephalon very much. We will in a subsequent lecture, but just, a foreshadow, the diencephalon is all things thalamus. So the subthalamic nucleus is part of the diencephalon. In the next set of slides, I'm going to show you what these nuclei look like within coronal and horizontal sections of the brain. In this section of the lecture, we're going to discuss all of the different basal nuclei and where they are within the actual brain itself. So this is a coronal section taken sort of near the front of the brain. I've kind of given you a diagram of where it is here. We can see the caudate nucleus and the putamen. And remember, these are part of your striatum. If you'll look at the slide a little more closely, you'll see that the caudate and the putamen are about the same color, which indicates that they have a common origin as the brain developed. The next section in is the globus pallidus here. And globus pallidus means pale globe. And you can see that it is actually a little paler than the caudate and putamen. The globus pallidus has two subdivisions, the internal segment, which is more medial, and the external segment, which is more lateral. A little bit further back in the brain, move this bar just a little bit towards the back, we still see our caudate, but it's smaller. We see our putamen and the globus pallidus. And now we start to see a couple of more parts of the basal nuclei. We can see the substantia nigra. And this brain isn't stained for anything. This is simply a fresh slice of a human brain, and this is what the substantia nigra looks out like naturally. Obviously, brown spot is what they named it because that's exactly what it looks like. And then here, it's a little hard to see, but there's kind of an almond-shaped nucleus here, and this is the subthalamic nucleus. So again, the caudate and putamen are part of the striatum, the globus pallidus is part of the pallidum, the substantia nigra is part of the brainstem, and the subthalamic nucleus is part of the diencephalon. Moving back even further in the brain, about this level, a little bit more further back, we've got a little more of the brainstem in this section, as you can see, because here's our pons. Again, we have just a little bit of the caudate left. We can no longer see, well, here we go. Here's just a little bit of the putamen on this side of the brain. We can no longer see the globus pallidus, but we see a very beautiful substantia nigra here and here. The reason we don't see nearly as much of the caudate in this image is because the caudate, I'll draw it for you, is kind of like a giant comma. And it starts out really large in the front and gets smaller and smaller as it goes back toward the back of the brain. So, oh, well, that doesn't, sort of like that. It gets smaller and smaller, trust me. And so when you see the caudate in the anterior sections, you see a very large piece of the caudate. It's called the head of the caudate. And then it's like a ram's horn. It curves around the lateral ventricles, goes a little bit more lateral, getting thinner and thinner all the time as it comes posteriorly. And the next section is a horizontal section, and you can see all the parts again. So in this horizontal section, this is the front, and this is the caudal pole. So this is occipital lobe, and this is frontal lobe. And the reason you know it's frontal lobe is because of your caudate. Caudate's your buddy. The caudate is always going to tell you exactly where you are in the brain. Just knowing where that caudate is, it's always in the anterior part, and it's always going to be medial to the internal capsule. We'll talk a lot more about the internal capsule when we talk about the cortex, but we alluded to it in the motor systems as being the place where, especially this posterior limb, where a lot of your motor information is passing out of the brain to go to the brainstem and the spinal cord. In this image, we can see the putamen. We can see just a little bit of the globus pallidus, because the globus pallidus, the pale globe, is kind of like a little ball that sits nestled within the greater structure of the putamen. We can also see the ventral thalamus. Can't really see a very good picture of the subthalamic nucleus in this particular plane, but it's in that zone. In the next set of slides, we're going to talk about the circuitry of the basal nuclei. So in the next several slides, we'll talk about the circuitry that makes the basal nuclei work and how it works with the rest of your motor systems. It's complicated. I mean, I cannot even go into how complicated it is. And for the level of neuroanatomy that I want you to know for this particular MOOC, I'm not going to ask you to memorize lots and lots of complicated, inhibitory inputs and excitatory inputs, because it's really, really complicated, and we're still learning quite a bit about this system. So we're going to just kind of talk in broad strokes. So in general, our motor cortex is up here. Motor cortex sends information not just through the internal capsule to your muscles, but to the striatum. And just for simplicity's sake, I just have the arrow drawn to the putamen. Other components are the globus pallidus, the subthalamic nucleus, and the substantia nigra. In general, the substantia nigra is sending information back up to the striatum. There's another part of the brain that's deep in the brain called the thalamus. And the thalamus is really important for both motor and sensory systems. It's a sensory relay that we talked about as that third neuron in the 3-neuron path for the sensory sensations. That made sense, sensory sensations. And it then sends information back up to motor cortex. So there are two pathways that I want you to be aware of. There's a direct pathway and an indirect pathway. The direct pathway facilitates appropriate motor programs. So the direct pathway, some of the differences between direct and indirect are going to revolve around the globus pallidus, the subthalamic nucleus, and their connections back and forth to the nigra and the thalamus. What I want you to know, and all I want you to know for this course, is that the direct pathway facilitates appropriate motor programs. So if there's something wrong with your direct pathway, you may be unable to initiate a normal habitual motor behavior, like you may be unable to initiate walking. The indirect pathway is involved in inhibiting unwanted motor behaviors. So again, the basic circuitry exists from nigra back to striatum, from thalamus to motor cortex, and motor cortex down to striatum. And again, there are going to be differences in how the globus pallidus and the subthalamic nucleus play into this. But the bottom line, and what I want you to understand and know for this at this level, is that the indirect pathway inhibits. So if you had damage to one of the components of your indirect motor pathway here within the basal nuclei, you may have unwanted motions, like a tremor perhaps, or some sort of unwanted writhing motion. Those are all going to be associated with the indirect pathway. So in summary, what I want you to know are what are the components of the basal nuclei, and what larger parts of the brain are they associated? Where are they in the brain? If I gave you a big picture of a coronal section, I'd want you to be able to point out the caudate and the putamen and the globus pallidus and the nigra. What's the basic circuitry? So those three big arrows that I had drawn on that on the diagram of the brain. And then really, what's the difference between the direct and the indirect pathways with regard to motor function? If you know all that, then you're ready for the assessment.